Yeah. Do we want to start now? Is everybody in, or do we wait for some more time? Hello?
What about others, sir? Is everyone are there? Still some are not joined, no?
Okay, so we'll wait for some time. Please let me know once everybody is in. I'll start.
You can just wait another 2-3 minutes, sir, then you can start.
Sure, sure.
What about others, sir? At what time they will join? What about Irene? Today only these many, or others is going to join? Somebody please reply, no?
Sir, in the class, most of them are joined, except Irene, sir. And others from the Sinjin, and they are not joined, sir.
No, they will join in sometimes, or today they won't.
Don't know, sir.
So I guess they won't come. Sinjin guys, they won't come, I guess. If we need it, we can continue, sir.
Okay. Then I guess we'll ask sir to start the session. Okay. Very good morning, everyone. Welcome to today's session. Today's session
Good
is
morning,
about autoclave cycle development and autoclave cycle validation by Mr. Veresh Kumar. That's it. Sir is going to join in, start in going to few minutes. So please wait. Okay.
Okay,
Sir, you can start, sir, actually.
Yeah, okay. So good morning, everybody, and welcome back to a session of interaction and learning. Today, we have covered a lot of topics around the autoclave, different type of autoclaves, understanding the autoclaves, understanding FO value, understanding Z, understanding D values. Now, the question or the last series on the autoclaves would be around what is the autoclave cycle development and how do we validate an autoclave, right? So there are two lectures which we are going to have today, two parts of the discussion, and in which I will be covering these two topics. So yeah, we have seen different kind of autoclaves, horizontal, vertical, pressure cooker type, double door autoclaves, etc. So just a recap on this, we recap on the sterilization processes. So we are talking about moist heat sterilizer here, nothing else that we are going to talk about. These are the different sterilization phases which we all are aware, which is pre-vacuum, with pulses, then pre-pressure pulsing, heat up sterilization, mold, post vacuum, and exhaust and cooling. So I'm not going to spend time on this. Factors critical to assure successful steam sterilization are time, temperature, moisture, direct steam contact, air removal, and drying. So again, very, very critical factors to remember all the time. Whenever we are developing a cycle, it is important to remember that we have to achieve these critical factors for a cycle to be successful. And when we validate it also, we have to look at whether we have done it in the set time, whether we have done it at the correct temperature, whether the moisture in the steam is at an optimum saturation level, whether we have a direct steam contact, because the penetration of the steam to the object to be sterilized becomes important, whether the air has been sufficiently removed, and whether the articles have been dried post sterilization. So these are critical factors which have to be considered during validation as well as during cycle development. Okay. So let's first talk about water cycle development. What is the purpose of it? So cycle development is an important part both for the autoclave procurement and validation processes. And why do I say autoclave procurement? Because before we buy any autoclave, we need to understand what is the capacity of the autoclave that we are trying to buy, what are the different type of cycles that we want to run in an autoclave, and therefore make sure that this is specified in the specifications that we share with the equipment manufacturer or a vendor, as I would call it in the rest of the presentation. That we are very clear of what we want out of an autoclave. Because please remember that just like in software programming, when you specify something, whatever you specify becomes an output. In the same way, if you specify something for an autoclave procurement, that becomes your input, and accordingly, the equipment manufacturer will manufacture it and give it to you. So you have to be very clear of what we need in the autoclave, and we will cover that when we do the validation part of it. And therefore, cycle development becomes an important part. So let's answer a few questions. When should one start thinking about cycle development? How does one determine the proper cycle type and cycle parameters needed to render the load sterile? How does one choose the sterilization process which does not destroy the load? And how does one validate the sterility of the load? So these are the questions that we need to think about. We need to start answering ourselves when we talk about cycle development. All right. First, to answer these questions, we should first understand what is the purpose of a cycle development. So, autoclave cycle development is a crucial process that allows autoclave users to determine the optimal combination of autoclave cycle parameters and loads to meet their specific process requirement. This design study occurs before validation studies and provides essential data for selecting which cycles and loads will undergo validation. So let's first understand this statement a little bit more clearly. We looked at the critical parameters here: time, temperature, moisture, direct steam contact, air removal, right? So a combination of these parameters is what is going to render a autoclave cycle successful. And what is the ultimate goal of an autoclave cycle? To make sure that the load which is put inside there, whatever is put inside the autoclave, comes out sterile, right? So whatever goods, whatever material you put inside an autoclave is referred to as load. And a load is whatever combination of materials you put in one go in a autoclave cycle for a autoclave batch. So to give you an example, let's say if we are running a sterile manufacturing facility, we may have certain tools and tackles like using spatulas, using certain kind of hoses, certain filter housings, maybe certain filters, garments, etc. So you decide that what is the combination of these items. Do I put the garments along with the spatula? Do I put the beta container along with the garment? So this you have to determine, saying what kind of loads do I want to put, and what parameter or combination of these for this load, what parameters like time, temperature, moisture will render the whole load to be sterile. And I will talk a little bit more about the loads. how we decide the loads, what are the different kind of loads as we go along in the cycle. But please remember that it's a autoclave cycle development is a factor of 2 points. One is the type of load and the other one is the parameter. Both are important when you talk about cycle development. Cycle development ensures that the load being sterilized is consistently and reliably sterilized every time. So, if a proper cycle development, once it is done and once you run the autoclave, you put those parameters, you put the load in, and it should consistently and repeatedly sterilize the load every time you put the load. Okay, it is only if a proper cycle development is done that your autoclave validation can be done properly, or your processes, your manufacturing processes can be rendered sterile. Otherwise, if your autoclave cycles are all over the place, then you will have problems because you don't know whether it is sterile or not. Every time you have to sterilize, you have to remove the BI, wait for those results. You can't wait for 5 days for a result to come out. Remember that we used biological indicators for determining the sterilization success cycle, correct? Now, in a similar fashion, if you have to keep on doing, and the biological indicators will give you results in 5 days. You put the biological indicator, you take the biological indicator out, you plate it in as a microbiologist, you will see the result of growth. If it's a total viable count, you will get it, you will start seeing results after 2 days of incubation in 37 degrees centigrade. But if it's a fungi, then the spores development will happen only after 5 days. And if they are sporulating microorganisms, it will require you to wait for 5 days. Now, for 5 days, can you wait for 5 days for every batch? You can't. So what is done in an industry is that you determine the parameters at which you are going to do the autoclaving. You determine the load which is going to get sterilized. You validate it, meaning you test it and say, yes, if I use these combination of parameters, I put the load in, I sterilize it with the BIs, and when I see the result, I'm getting no growth. Now, after a couple of days, after 5 days, again I put the same load, same conditions, repeat it, but the load now is dirty because I have washed the clothes after the first cycle of autoclave. I've used them and then I have washed them and I've put it back again. Now I do again a cycle. Yes, there is no growth. Unless and until you repeatedly achieve these parameters of consistency, that yes, these set of parameters with this load is giving me sterilized load. You validate this. You say, okay, this is my parameter of the cycle for this load. Now, during sterile manufacturing, you don't have to do anything. You have to go ahead and just run the cycle, and you are 100% sure that the load is going to be sterile because you have already validated it, you have tested it. Does not mean that you will not put BIs in the cycle. In every cycle, you will put a couple of BIs and you will plate it as a control sample. You will do a control in any test that you do in quality assurance and quality control. I'm sure Lakshmi madam would have covered it in her quality control topics. You always do what is called as a control sample. What is a control sample? It's a sample that you put for a study to see that your whatever test you are doing, whatever activity you are doing is correctly performing. So even when we do in a lab, let's say simple titration test, we generally use a known sample, known of a known quantity, which is called as a control sample. Titrate it and make sure, yes, my I'm getting the right kind of titration with so many ml of the buffer. I'm able to titrate the mixture, which means that my system is okay. And then you take the test sample, the sample to be tested and subjected to the same titration or the same test, and you're sure that yes, now the result which you're obtaining, the instruments that you're using, anything that you're using is not flawed. In a similar way, in an autoclave cycle development also, after you have finished the cycle development, with every autoclaving that you do in actual manufacturing, you will leave certain BIs within the load. And these are based on worst case conditions, and I'll explain a little bit about what the worst case load and worst case conditions are meant as we go through this process. Okay. When should the cycle development be thought about? It should begin before the sterilizer is purchased, because the cycle type will affect the type of autoclave we need, and changes in the field after installation are generally difficult and expensive. You can't make a change in an autoclave after you have purchased it. It is installed. Therefore, it is important to think through. If I remember correctly, in one of the topics on FO, I had shown you a sample URS, or user requirement specification of an autoclave, right? So it is very, very important to determine the autoclave cycle before you even purchase it, so that you know what I'm going to autoclave, so that the sizing is correct. You don't oversize the autoclave, you don't undersize the autoclave. Undersizing an autoclave would mean you'll have to do multiple cycles, which increases the wait time before you can start a sterile manufacturing process. And oversizing it means that you will unnecessarily waste too much of steam or resources, because steam and vacuum both will be used, and in both cases you will unnecessarily waste the resources, because now you have a much larger chamber with a smaller load being sterilized, and therefore you will need to expend energy just to heat up the autoclave itself. Because remember, autoclave is made out of metal. The metal has to get also heated to 121 degrees centigrade during the sterilization cycle. So oversizing an autoclave and undersizing an autoclave both are detrimental to the sterile manufacturing process in terms of cost and time. So it is important to understand this, and I'm not saying you will know everything 100% when you start purchasing it, but generally you should know, okay, I'm going to have a garment, my quality policy says, or I'm going to have a quality policy which says I will have the garments sterilized separately, and any component which I use in the manufacturing process, like hoses, spatulas, filter housings, filters, as one as a different cycle. All the cleaning materials like my wipes, my mops, my disinfectant solution would be another cycle. So I know I have got solid loads, I've got liquid loads, I've got garment type of load. So I know the type of load which I'm using. I'm going to run at least 3 sterilization cycles before I can start a batch. Therefore, I need that size of an autoclave. Or, okay, my manufacturing process requirements are smaller. I'm producing a low volume, high value product. I can combine, say, the components and the garments in one cycle, and I will use the cleaning wipes in another cycle. Or I may combine everything together, and that's still possible. So it is important to have this clarity before we purchase it, so that we know what kind of a sterilizer we should purchase. Okay, again, we saw whether it should be double end, horizontal, vertical. All those are very, very important from a perspective of determining the sterilizer cycle development has to be defined, sorry, before you purchase the sterilizer. Okay. Now, what are the different type of steam sterilization cycles? Okay. It goes without saying that not all loads can run with the same sterilization cycle. That's a given. You don't use the same type of cycle for every different type of loads. This is why autoclaves are equipped to run with various cycle types. Unfortunately, choosing a cycle type can be confusing, not to mention confusion around selecting the proper sterilization time and temperature. There are uh, 3 major cycles which are used, and we have seen this, or we've studied this in the earlier sessions. But these are the cycles that you would run. Okay, one is gravity and liquid cycles. In both cases, you need to preheat the load through gravity displacement. You remember gravity displacement, steam displacing the air, in which you admit the steam into the chamber, hold the temperature constant throughout the exposure phase cycle. The difference between a gravity cycle is that you evacuate the air by using the drain. Okay, in liquid cycle, what happens is that liquid cycles are used in terminal sterilizers or in disinfectant preparation and all that. In that, the pressure and temperature have to be kept at a lower value. In terminal sterilizers, you do not use 121 degrees centigrade. You are generally operating at 110. Why? Because your liquid load can start to boil. If it starts to boil, inside the package which it is there, it is going to create a pressure and therefore can have the packaging itself burst. So to prevent that, you have to know what is the temperature and pressure at which you should do it. So you do not want the liquid to boil, and therefore you do not want to combine it with a load which is a dry load, because if you combine it with a dry load where you need to go to 121 and your liquid starts to boil, you will have a problem. So, depending on the type of cycle, you may run a gravity load and a liquid load. Liquid load or a gravity load. So, you will use gravity displacement for removing the air, and you may have a solid load or a liquid load. Okay. The second type of cycle is vacuum cycle, where you use multiple pulses of vacuum followed by steam injection to remove the air from the chamber and the load. And then you definitely steam it up, hold it, and then you go to the cooling phase. During the cooling phase, you may or may not use vacuum, and that's a choice that you would do depending on whether you want the load to be dry or not. So there is vacuum cycles. Now, you can use vacuum cycles for solid load as well as liquid source. So the first cycle is a gravity cycle. Second one is a vacuum cycle. Third is an air over pressure cycle. In air over pressure cycle, what is it? Air and steam mixture for terminal sterilizers. We learned that down in the earlier sessions. Again, if you have an air and steam mixed together, and therefore you are preventing the boil up of the load, then that is called as an air over pressure cycle. So you have gravity displacement cycles which run on pure steam and have temperature either at 121 degrees centigrade or a lower temperature depending on whether you are using a solid or a liquid. Then you have the sterilization cycles using vacuum, again using pure steam, saturated steam, generally at 121 degrees centigrade, but using vacuum as the means of evacuating the air. And then you have an air steam mixture type of cycle which is used. So these are the three major cycles that you would use in a autoclave's determination of what kind of an autoclave you want to buy. And generally for the laboratory, gravity types are more than sufficient because you have not very large quantity of loads. For a manufacturing process, you would use a high pressure, a vacuum type of sterilization cycles. And in terminal sterilizer, you would either use gravity type or a steam air mixture, or you would use directly steam and run it at a lower temperature. So these are the three major loads which will tell you which type of an autoclave you are going to buy. So here is a type, here is a small cycle determination chart which helps you what kind of a cycle you should use. Okay, you have an unsterile load. Is it liquid or does it contain liquid? That's the first question you have to ask. If the answer to that is yes, is the container flexible with residual air inside? So if there is residual air and the container is flexible, then you can use a steam air mixture, no problem. If the answer to that is no, then you have to ask a question: does the liquid have a tendency to boil over easily? If the answer is yes, then you use an air over pressure cycle. And if the answer is no, then you can use a liquid cycle. If the tendency to boil is not there, you can easily use a liquid cycle. If the tendency is there to boil, then you will not use a liquid cycle. Okay. Then if does the liquid contain liquid? If the answer to that question is no, then can the air be removed easily? Are there no restrictions on air removal? If the answer to that is yes, you can use a gravity cycle. If the answer is I don't know whether I can use the I can remove the air or not, then I will use a pre-vacuum cycle. So very clearly, I use a gravity cycle only if I can remove the air easily from the load. I use a pre-vacuum cycle where I know that it is difficult to remove the air from the load. I use, and depending on whether my load is liquid and can boil over or not, I can choose between air over pressure and steam air mixture. Now, the the question is which one is right for me in a sterile manufacturing process. In a sterile manufacturing process, generally you may not always know whether it is difficult to remove air or not, because you may over a period of time in a sterile manufacturing use different components. In such a situation, you may have to use a pre-vacuum cycle as a default cycle. Only when you are using liquid lots where you are terminally sterilizing a product, you will use the steam air mixture or air over pressure as the criteria for selection. Whereas and you could, of course, it does not have a tendency to boil, you can still use a pre-vacuum cycle, but a liquid cycle, so that your temperature is not at 121 degrees centigrade. You can manage it at say 110 or something like that, and still using vacuum you can go ahead and sterilize your load. Gravity cycles, as I said, is uh, on a large sterile manufacturing process may not be applicable all the time, because it is difficult to take the load, and very simply because if you look at the size of the autoclave here, if this is the size of an autoclave, this is a picture of a 2000 liter or a 1500 liter autoclave, it is very difficult to determine how to how to remove it. If you are using a small autoclave like this, which is a laboratory autoclave or a autoclave of these types, then yes, a gravity cycle works much better. Maybe it may work even for a small size autoclave like a 300 liter or so, but when it comes to anything larger than 300 liters, generally pre-vacuum is the preferred process. So this is not a default, but it's a generally a practice which is used in the industry, that possibly we will use pre-vacuum for sterilization of components, and steam air mixture if the for most of the terminal sterilization processes. And you can have terminal sterilization equipment which can run on multiple cycles. It can use a steam air mixture or air over pressure with the same equipment. So sometimes it also helps in specifying when you are making a user requirement specification to say that I want both the cycles to run in the same autoclave. Some people, it is difficult to have pre-vacuum steam air mixture air over pressure on the same equipment, because that makes the equipment pretty unflexible and expensive, because the vendor has to then create provisions for all three, which is very difficult. It's not impossible from an engineering standpoint of view, but not a preferred route. So you will generally see a terminal sterilizer being a separate equipment, and an autoclave which is used for component sterilization as a separate equipment. Sometimes people do use, and in sterile processes, very clearly you won't use something for decontamination, where you use for sterilizing a load which is used in sterile manufacturing. So you will generally see a decontamination oven separate, or a decontamination autoclave separate. You will see the autoclave used for component sterilization separate. You will see a autoclave for terminal sterilization separate. So these three are definitely the type of autoclaves used see in a sterile manufacturing process. Now, once you have decided what is the cycle type, then you have to determine the cycle parameters. And we have gone through FO and time cycle calculations. We know how to calculate the FO depending on the temperature. So you determine whether the load is sensitive to a temperature, whether it can withstand 121 degrees centigrade or not. If it cannot withstand 121 degrees centigrade, then we determine the load based on the FO value, or the time based on the known FO value. So if we know the FO value from previous experience, from a lab data point of perspective, we can use the FO value and then determine what is the time which it will take to sterilize the load. And based on that, we can define whether for the autoclave should be X liters or Y liters. So in all steps of autoclave selection, your FOZD values, all these three are very, very critical and important. So please make sure that these are used in your cycle determination. The third part, of course, is to validate the cycle itself. Okay, and please remember that when you do a cycle determination, it's always based on a yes no. So there is a probability here of a guesswork which you have done, because you may not always know the load type. If you know the load type, you're scaling up a known process, a known. Let's say you have a facility which was running 1 million doses every year, was producing 1 million doses, and now you are saying, okay, now my business has grown up from 1 million, I want to go to 10 million doses. So I exactly know what product I'm doing, I exactly know what kind of equipment I'm going to use or loads I'm going to sterilize, and based on that, I know what kind of cycles I want to use. Then it's not a guesswork. But when you're designing a new facility, a multi-product facility, a lot of times, please remember that any facility of sterile manufacturing, when it is designed to run for at least 15 to 20 years, right, of its life cycle. And during those 15 to 20 years, the product portfolio is not going to remain the same. So it's generally that you are going to see a variation. So you will need to change the loads, and you will need to change the type of material which goes for this thing. So it's generally a best guess that you would do on a cycle time, sterilization temperature, and sterilization time. Once you have taken this three decisions, what is the type of autoclave that I want to use, and what cycle I want to use, what is the sterilization temperature and sterilization time, you need to validate the cycle to ensure that the load will be sterile. Now, how do you do the determination? Okay, the test cycle should be loaded in a way that it is representative of the actual load to be sterilized. It is recommended to run the test cycles at half of the desired sterilization type. This is referred to as hive cycle method. So in while validating, what happens is that you now have the autoclave. Now you've got to validate it. You cannot validate an autoclave before you purchase it. So your first part, which was determining the cycle type, determining the temperature, determining the time, gave you what type of autoclave to buy. Now you've got the autoclave, you need to validate the autoclave. So what do? You have to run the test cycles. So how do you test cycles? You have to do an empty load, zero load, meaning that without having any load, you place the biological indicators inside the chamber, and then you run the sterilization cycle at 121 degrees centigrade for 30 minutes, and first determine that with zero load, just with the components of the autoclave, which may have certain stands, may have certain basic metal which is already there, you are able to achieve sterilization consistently at a certain temperature and time. So this is your zero load condition. Then you take the representative load. You may take a set of garments, or you may take a set of solid loads, and you will load inside the autoclave, and at the predetermined temperature and time run the sterilization cycle with the BIs being there. And then once that sterilization cycle is completed, you will take those BIs and plate them to make sure whether they are sporulating or not. Now, one of the methods is that I had determined that I would require 30 minutes of time. Instead of 30 minutes, I will run the cycle for 15 minutes and see whether my BIs have passed or not. If my BIs have passed, then I know that I can run it at the time that I had asked for it. If the BIs don't pass, then I know I have to change, I have to run it at full load, or my load pattern has to change so that I can achieve the sterilization. So half cycle is used, but generally if you have determined 30 minutes, then you would also run a test cycle with 30 minutes to make sure that you have the right thing. Now, why do you do a half cycle method? Is initially when you are when you are developing the cycle, you will run a half cycle method to just say whether your BI placement is right, whether your choice was right, whether your load pattern was right. If in the half cycle method itself you see that it is um, what do I say, passing, then you know that you are in the right track, you can run a full cycle. But in the half cycle itself, it is failing, then you need to relook at how you place the loads, what is the time calculation, temperature calculation, and make sure that you make changes before you run a full cycle. You cannot validate a autoclave with a half cycle. It is only a method which is used to quicken the process of cycle validation. But for actually validating, you will have to run the whole cycle. Sterility testing is confirmed using BIs. Now, BIs are placed in intimate contact with the load and are placed throughout the chamber. So, you have the loads placed, you have the hoses, you have the filter cartridges, you have the garments, you place the BIs within those components, like inside a hose, inside a filter housing, within the garment, and allow it to be under steam sterilization. Take those BIs and plate them to make sure that it is done. Now, for dry loads, spore strips can be used. So there are strips like this which are available, which can be used for dry loads. For liquid loads, we can either use a hermetically sealed ampule. So this is an ampule which is there, or it can be inoculated actual liquid load. You can take the liquid load itself and inoculate it on a challenge organism and culture it after the cycle is complete. So there are two ways of doing it. You use a predetermined BI in an ampule. So this is a vial, this is an ampule, both are available. Okay, and it can be placed even if it was, let's say, a filter housing that you were doing. You could use a BI like this by placing the load in a specially designed gasket and leaving it inside the filter housing, so that you can see whether it is getting thoroughly sterilized inside the filter housing or not. So different type of biological indicators are available. There was a time when these were not available. Today these are available. Apart from this, there are thermomelt stickers, so you can use stickers which are placed so that they change color the moment they go from to 121. So you can place these stickers or thermo markers, as they are called, in different part of the load and the chamber to see whether each of those parts has reached 121 degrees centigrade or not. So a combination of BIs, thermal stickers, sometimes even chemical indicators can be used to determine whether your cycle is successful or not. Okay. The BI should show no growth and 3 consecutive cycles. If when you run the cycle once, you plate them, you again load it at the same parameters, you run it third time. So each after you do 3 successive cycles, one after the other, at the same condition for the same load pattern, then if you have no sporulating growth, if you have no growth in the BIs, which means that your parameters are correct, your cycle is validated. Very, very important to make sure that a validation is done. So there is determination of the cycle, determination of the parameters, and last, validating the cycle. Now, I'm going to stop here because if there are any question and answer here, we are going to get into the validation part of the validation part in the next set of session, in the next session. So if there are questions up to this point, I want you to ask. I'm going to then allow you to take a break for 5-10 minutes, and then we do the second part, which is the actual autoclave validation itself. So, anybody has questions, please go ahead and please shoot. Students. Any questions, students? No questions?
No, sir.
Okay. Did I manage to doze you guys off, or was it a session where you understood everything? Okay. So if there are no questions, I will just spend a few minutes more on this session because we've not exceeded the time allocated for the first lecture, and get into certain definitions so that when we go into the next session, where I want to spend more time on explaining you the qualification and validation, these definitions are going to help. So these are already there. I'll quickly go through them so that you can understand these. Dwell period is the time period when the autoclave temperature has reached the set point 121 degrees centigrade at such steam pressure of 1.2 bar, or 110 degrees centigrade at a certain pressure, and ends when the time is expired. And you've determined that this time is going to be 30 minutes, 20 minutes, 36 minutes. We did that exercise in one of the sessions earlier. And in that session, you determine what was the time required for sterilization. That time which is determined there is called as the dwell period. Worst case items in the load which are most difficult to sterilize and is determined by steam penetration study. So for any item which you need to sterilize, there is something called as a steam penetration study which you will do to see whether the steam can penetrate the load, or is it easy to sterilize or not. And in such a situation, if you find items which are not getting sterilized easily, these are called as worst case items. Worst case location is a location within the item which is more difficult to sterilize. So let's take a garment, for example. A garment is a shirt and a pant kind of a situation, or the top and the bottom, right? Or it could be a complete overall like a boiler suit, right? In such situation, you have different areas. You have the sleeves, you have the neck region, you have the leg and the neck region which are combining together. You have the calves, you have the ankles on the pant side. When you place this load, you will place BIs in different locations within the garment, fold it and sterilize it. And you might find that one particular area is very difficult to, within the garment, is difficult to sterilize. It's taking a little extra effort. Instead of 17 minutes or 20 minutes, it is taking 25 minutes for you to sterilize. The reason is because the steam to reach that spot within reload is taking a long time. Now, if you had a long hose, for example, you're using 2 meters of a hose, your autoclave is not going to be 2 meters long, right? So you will have to coil the hose, you will have to place the BI in certain positions, and you will have to determine which is the difficult part. Now, as an engineering guess or as a standard guess, people would say the center of the hose should be the most difficult to sterilize, should be the worst case location. Not always true. Sometimes it is the edges which are difficult because the edges have an ease of the steam entering and getting out of that place and not staying there. Whereas in the middle, the steam has sufficient time to stay and heat up the whole hose. So in such situations, your worst case situation, your worst case item could be a hose within the load, but the worst case location within that hose could be an area which is very close to the entry or the end connection of the hose. Right now, all these things are studied through a steam penetration study, and you determine. Gravity displacement, I'm not going to speak about. We've already spoken about it. Vacuum cycle, pre-vacuum, post-vacuum, yes. Hard good cycle, a sterilization cycle designed for items for which air removal is not difficult, and therefore generally one pre-vacuum is drawn. So hard good cycle is, okay, goods are solid in nature. If you apply one vacuum, air gets quickly displaced because the air has not penetrated the load. Air is not resident within the load. It is easy to determine, to remove it. Wrap good cycles, they are generally where you need to wrap the goods. So what are the goods that you need to wrap? Garments, for example, certain needles and small components which are used in the filling machine. These are wrapped goods, and the air is difficult to remove. Why? Because the wrapping itself, you have to remove the air from there and allow the steam to penetrate. So you use what is called as a Tyvek bag. Tyvek bag is something where you will wrap it, allows the penetration of the steam also. Liquid cycles, we know what liquid cycles are. Bowick test we have already studied in the past. I'm not repeating the thing. Empty chamber test, as I told you, when the autoclave is empty, nothing is kept. You just do an empty sterilization cycle so that you know that the autoclave can be uniformly sterilized at that particular condition. Steam penetration test, loaded chamber test designed to determine the worst case item and the worst case location within a load. These are steam penetration tests. Biological challenge test, loaded chamber test designed to challenge the worst case location within the worst case items with biological indicators to demonstrate the effectiveness of the sterilization cycle. So once you do a steam penetration test, you know a load is difficult. At those locations, you will place the biological indicators also, and then run the cycle to say whether your cycle was effective or not. Load, autoclave load refers to the items that are being sterilized in an autoclave. Very simple definition. Fixed load. A load configuration where the quantity and location of the item within the chamber are fixed. So fixed load means quantity and location. Where you place it inside the chamber and how much you place is fixed, is called as a fixed load. There is something called as a variable load where you may not have the quantity fixed within the chamber. There are certain cases where both quantity and location are not fixed. So there is fixed load, which is quantity, location fixed. Then you have fixed load where the quantity is fixed, but the location may change. Then you have a variable load where the quantity may change, but the location may be the same. And then you have the variable load, completely variable load, where the quantity will also change, location will also change. Now, these are real life situations because if sometimes you have a certain new product coming up, then you may have variable loads. Sometimes you may need extra quantities of garments because you are running a media fill, or you have had a problem in the previous batch, and now therefore there are two people more from quality assurance who want to come and stand while the process is going on to see it. So you may have extra garments which are required, or you may have extra hoses which are required because you found that when you were when you were trying to run the process, you were waiting for the hose and therefore your time extended. So to cut down the time, you need to place more hoses. The quantity may change. The location within the autoclave you determine. Imagine a cube. Imagine a cube. In a cube, you have different locations. So you can place it on the top right hand side, top left hand side, top right hand side in the front, top right hand side in the back, so on and so forth. Bottom, middle. So you have different locations which are there. So you always fix a location saying I will always place garments on the bottom right hand side. I will always place hoses on the top middle left hand side. I will always put filters on the top right hand side, for example. These are locations within a load, and these are determined. Remember, we talked about trolleys, right? Trolley inside a sterilizing chamber. This is a trolley. Now, where you place the load within this trolley is called as a location. Please see this photograph here. How they have placed the loads. They have placed certain type of loads here, certain type of loads here. So this is a location which you determine on a autoclave cycle. So very important to understand that the location of the load is determined, quantity is determined, and in a standard sterilization manufacturing process, meaning for a well established process, you will not see a variation on the quantity and location generally. You might have some spikes. So when determining a load, you will generally keep three extra garments. What happens if somebody had a emergency and he had to go out of the room and then come back again? He can't use the same sterile garment. He has to put another extra one. So you always, if you had say four people working inside and you needed to sterilize the load for that four people, you might probably sterilize 6 or 8 garments, so that in case the person has to go out and come back, you have sufficient quantity. So this determining the quantity inside the load is itself as a exercise which has to be done to make sure that the quantity is also determined, so that you are an optimal quantity. You don't want to over burden. You don't want to, let's say, sterilize 20 garments and then use only 10 out of them. The 15 have to be re-sterilized. Then that's a waste of energy. So it's an optimal load quantity. Once the quantity is known, that I need to sterilize, let's say, 15 garments, I need to sterilize, let's say, 10 hoses, I need to sterilize 5 filters, I need to sterilize 3 filter housings, I need to sterilize 10 needles, etc., etc. Then you fix its location. Where is the best possible location based on steam penetration studies, and therefore you make sure that they get sterilized consistently. So both quantity and location are important. They are generally fixed for a given process, but can have variations sometimes also. Why the location can vary? Sometimes you are dependent on an operator loading the autoclave trolley. Now the operator may make mistakes. The operator can place a load in the wrong place. So generally the quantity will be fixed, but the location is a variable in 99% of the sterile manufacturing cycles. Whereas only in case of new products, in case of very specific cases, your load quantity and load locations will both vary. So generally the load quantities will stay fixed, but the location could be a variable, and this is the real life situation that you will see in the industry. Okay, so with this, I'm going to stop here, because now I'm in the next session. I want to spend only on the validation. We are at 10:25. We will give a break of 15 minutes here. Yes, exactly at 10:40. We will start the next session. Is that fine?
Yes, sir.
Okay, so I'll see you guys in another 15 minutes. Yeah, is everybody back? Students, I see 18 participants were there in the last session. There are only 17 now. Who's missing? Can somebody answer, please? Hello.
Hello, sir.
Yeah, is everybody back?
Yes, sir.
Okay. Should I start?
Yes, sir.
Okay. So this session is going to be around cycle validation approach. I'm going to explain to you how a validation of an autoclave is done. So the approach over any cycle validation follows this flowchart, which is here. User requirement specification is the first step of any validation, where you need to have a proper specification specifying or stating what you are expecting from an equipment. And this is not true only for an autoclave, but would be true for any equipment that you purchase in a pharmaceutical manufacturing facility. The design qualification is the next step, and I'll come to explanation of each of these functions. But the second stage of the validation is what is called as design qualification, which would include functional specification. The reason why we bring in the aspect of functional specification is most of the equipment today have a certain amount of automation or level of automation. The construction of the equipment is the next phase, followed by what is called as a factory acceptance test, where before the equipment leaves a factory, you have to have a factory acceptance test. The factory the user goes to the factory and make sure that everything what was specified in the user requirement specification and design qualification is achieved. Not all the tests can be carried out during a factory acceptance test, so the majority of the tests are done during factory acceptance test, and then based on this you release the equipment for dispatch. The equipment then arrives at the manufacturing site, where your installation happens and you qualify the equipment from an installation perspective, followed by an operational qualification and followed by performance qualification. So what each one of these phases are, I will come to. Now, this is a model. Overlaying all these is called as a validation master plan. So you would have determined how you are going to validate it, and that's how it is. Now, what I'm showing you on the right hand side is a V approach to automation, and this is an automation approach for validation, which is generally followed in the industry, called as the V model of automation validation or automation computer system validation. Also becomes applicable for equipment in a way, because the steps remain the same. But for a computer system validation, why is it called as a V approach? Because it is, I mean, the components are arranged in a V shape with some overlap between the initial phase and the qualification phase, and that is why they are arranged in a V shape. And because of the shape itself, they are called it's called as a V approach to validation. Of course, there are different models, but this is the most widely used approach, and that's why I'm presenting it here. So you prepare what is called as a validation master plan, A master plan where you say, okay, what is it that I'm building the factory for? What is it that I want to, what are the different components, equipments, etc.? How am I going to make sure that I'm going to qualify each of these components, be it infrastructure, be it equipment, be it computer system validation? And that is your original plan. This is called as a master validation plan. This, of course, gets updated during different phases of the project, but validation master plan is the key plan which tells you how you're going to make sure that the facility is fit for use. The URS is again a part of this automation system also. FRS is something that is either written by the vendor or you write it, and this is important. So this is a part of DQ. Technical requirement specification. So this is where the hardware and the software specifications get written down. Construction, which is a factory acceptance test, and whatever you can't do in the factory, you will do it at the site. So that is why this is combined here in case of a software. Then you do an installation qualification, operation qualification, performance qualification, and of course you have to maintain the state of validation. Matlab, you have to repeat certain tests over periodically for an equipment or for a software to make sure that it is remaining qualified, meaning it is validated. Even in an autoclave validation, what happens is that you establish your cycles, you validate the cycles, and you start running the process. Once in a year, once in a 6 months, you have to repeat the validation cycles to make sure that your equipment is maintained in that validated state. Why is it? Because things might have changed, parameters might have changed. Your steam line which is used, you had initially validated it when you started production. At that time you probably had just two products which were known and you were running two products. Then midway, after 3 months or 4 months, one more product got added, your number of cycles went up. The same loads, you ran two autoclave cycles instead of one because you had a requirement for an additional product which came up. The cycle remained the same, the load remained the same, but you said load one is the same load. I run one cycle, I wrote another cycle. So instead of running four sterilization cycles, which were standard, I run a fifth one or I run a sixth one. So over a period of time, you are aging the equipment, you are aging the systems. Therefore, you need to requalify and make sure everything is okay. Your temperature probes are calibrated, and you have to get them. You have to check the calibration once in a while during preventive maintenance. So once a year, generally every year, you repeat the validation to check that it is maintaining a state of validation. So this is the process flow for validation. Now I will get into each one of these items to explain you what it is. So user requirement specification, a written document which is issued by the manufacturing process team. And why do I call this as a manufacturing process team and not a specific person? Is because there is a team from the user side. The company which is going to do the sterile manufacturing process is called as the user, and there is a team which comprises of the manufacturing plant operations, meaning the people who are actually going to run the manufacturing process, the engineering, which is your maintenance guys, your operations guys who may be other functions like projects or could be other management representatives, EHS, which is your safety and health system people, and quality control. So this is the team, which is a group of people who are assigned the responsibility as a manufacturing process team, who have to write the URS or at least determine the URS and sign off. Now, the URS may be written by, let's say, a manufacturing guy or a consultant from outside and given to the manufacturing team. But these are the people who are to review and approve the URS. because it is important that a URS is the mother document which is going to a manufacturer so that they can produce the equipment as per your requirement. So your cycle development, your load determination, all are the inputs which go into it, the capacity of it. So what is the content of a URS? The intended purpose of the equipment. The first thing you have to write is what is the purpose of these equipment? What am I buying this equipment for? I'm buying autoclave to sterilize a liquid load, a solid load, or a combination of loads, whatever it is, you have to determine that. So that is the intended purpose of the equipment. What are the roles and responsibilities of the equipment supplier and the users? What is the responsibility of the supplier? What is the responsibility of a user? The type of sterilization cycles that you're planning to run, the details of the load or the types of loads that are going to be sterilized, the capacity of the equipment required, the automation and control requirements. What is the automation requirement? Do you want a fully automated process? Do you want a semi-automated process? Do you want an automated process which can be monitored remotely from, say, thousands of kilometers away by your head office, sitting in your plant could be, let's say, in Jammu and Kashmir, and you want to be able to monitor that from Bangalore, which was your headquarters. What kind of automation control do you want? Do you want a PLC based control? Do you want to have a automated batch record generated out of it, or do you want to have a combination of a manual record and a or electronic record? So this is all determined from automation and control requirement. The critical process parameters for quality control required for the same purpose. What is your temperature cycle? What is your temperature time for this thing? What are the other critical parameters that I have to run a bovetic test every time that I run a sterilization cycle? Every time that I do this, I need to monitor the temperature at five different points in an autoclave. At the worst case, inside the chamber, inside the load, at the inlet of the etc. I want to monitor these. So these are some things that you determine that what are my process parameters from a user perspective that I want to monitor. And some of these comes from experience from previous run facilities. Some of it comes from previous experience of a person who's running the manufacturing process itself, and some of it also comes from the regulatory perspective, saying what the regulator is expecting. So these are the critical process parameters which are put in there. What are the critical alarms and features required for the equipment? What are the critical alarms that you need? What are the if at what stage should an alarm be generated inside the machine? Should it alert you? Should it raise an alarm? Should it, so that you make sure that even while the process is running, you do not have a problem. Give you an example. Let's assume that the power failure happened in the not in your manufacturing facility because it was on uninterrupted power supply or UPS, but your main boiler, which is like a 2-ton boiler which is sitting in a boiler house outside. Suddenly the power failed. Now that boiler is not going to go on instantaneously as soon as power comes back. So you may have power failure. The government is supplying you power through the electricity distribution company. The power fails. When the power fails, it is likelihood that the boiler will stop working because there's no power into it. Now, in that situation, you might have a diesel generator set which will kick in to give the power so that the facility can continue its operation. But there is a time lag of, let's say, 5 minutes. During those 5 minutes, steam has not come into your plant. As a result of those 5 minutes, your steam pressure or temperature of the inlet steam, the pure steam which you are injecting into the autoclave, may have dropped slightly. Now, if such a situation happens, you need an alarm saying that I have a situation where my power has failed. Now, what do you do in such situation to the autoclave? Do you stop abort the cycle, or do you continue the cycle by putting the load on hold? Meaning that there is a timer which started at 121 degrees centigrade, or 123 degrees centigrade. It ran for 22 minutes and the power failed. you are 100% sure that you will get back the power in 2 minutes or 5 minutes, and your steam pressure will be back to normal. So I don't want to abort the cycle. I will continue to hold it at that temperature for a little longer till it does not fall below 121 degrees centigrade. And after that, as soon as the power is up and I get the steam power, I'll stop my timer. So at 22 minutes, I'll stop my timer. I'll still monitor the temperature, and then I will restart my timer as soon as I regain the condition. Say after 5 minutes, at 27 minutes, I start and continue for another 8 minutes or 10 minutes. Now, this is something which is a critical process parameter as well as an alarm which is generated. You write this down in the user requirement saying what is it that you want. You will not write it in this specific terms that I said, but you would say, I want an alarm when there is a power failure. I need an alarm if my steam pressure goes below this. I need an alarm if my vacuum pump does not come on. I need an alarm if my chill water is not okay. So whatever those critical process parameters are, the alarms are specified because they are critical for you as a user to be there on the equipment. What is the documentation requirement? What are the documents that the vendor has to give you? He has to give you the PNID, material test certificates, so that you know that it is made out of the right quality of material. You need to give the welder log report so that the welding is correct. You need them to give a boroscopy report. You need to give them the to get the certificate from USP6 for all the elastomers. Whatever be your documentation requirement for the automation, you need the specification of PLC. They may be bought out components. Not everything gets manufactured by the equipment manufacturer. He buys components, right? So he buys, say, a vacuum pump from somebody outside like Edwards uh, or Bosch or whoever it is. He buys the electrical components from L&T. He buys the PLC from Siemens. He buys the IPC from Siemens, or the HMI from Siemens or Allen Bradley. These are called as third-party components which are integrated by the equipment manufacturer. In such a situation, you need the operation and maintenance manuals for these. You want a calibration certificate for your instrument. So whatever be your documentation requirement, you will specify it as a part of the user requirement specification. What is your qualification requirement? What are you expecting the vendor to support you during qualification? So is he responsible for what are you expect? Okay, he will need to give you the design qualification documentation. He has to give you the functional specification. He has to support you during factory acceptance test. In the factory acceptance test, you are going to run in his factory the following minimum tests. You may run more, but minimum tests are specified. You want him to be responsible for doing what is called as a site qualification, meaning support you during the site, do the IQ and OQ of the equipment. He does the commissioning of the equipment at your site, after which you take over the equipment. So these are the support that the vendor is going to give you, or he's taking the responsibility for qualification. So those are also specified. Safety requirements are specified, that I should not, the hot surfaces should be insulated, that if the pressure inside the chamber is X, then it should not allow me to open the door, that there should be a ruptured disc in case the pressure exceeds the design pressure. The design pressure is that I'm going to run the autoclave at, say, two bar maximum pressure. If the pressure keeps on building inside the autoclave beyond 2 bar, there should be a ruptured disc which should go up, or a safety valve which should come on, so that your the equipment is safe. You do not want the equipment to get destroyed for whatever reason. So safety requirements are specified. For electrical, you might have what is called as a lockout tagout. When the somebody is doing a maintenance work, you lock out and tag out the equipment, so that the equipment cannot be switched on till the maintenance work is over. So these are safety requirements which are also specified into the user requirement specification. Sometimes you mention things like, what is your timeline for procuring this equipment. Sometimes you write down other specifications also, but what I've listed here is the minimum thing which should go into a document. A user requirement document is signed by the person who's preparing it and the people who are reviewing it, and finally approved generally by quality control or quality assurance team member, who is called as the user or the super user and is submitted to the manufacturer. The manufacturer will then review this document from his perspective and will come back to you with the confirmation that yes, I will be able to build the equipment as per this URS. And he will then submit a quotation for this, which you will review it. You will review it from a perspective of the fact that he has met all the requirements of your URS. Sometimes there may be deviations. The deviations could be minor in nature or major in nature. If they're major in nature, of course, you can't work with a given vendor. But if they're minor in nature, sometimes it is possible for the team, the manufacturing team, to take a call and say, yes, okay, it was a nice to have feature on a autoclave, but it is not something which was a must have. It was not very critical for me. It was put there so that I could be future ready. For let me give you an example for this. Let's say that a vendor is not able to provide you a feature on his automation system which allows you to generate electronic batch records out of this equipment. Now, it may be a nice to have feature today because you are not planning to put your entire facility on an electronic batch record. Okay, in such a situation, you can say that I want to have that connectivity for the future. But today, if a vendor is not able to give it to you, and because of certain restrictions of of certain things, then you may be able to say, okay, it's okay not to have this feature today. Or let's say another feature for an autoclave I'm just trying to think of, which I would call it as a nice to have, would be that I would say that I want to use an IPC with a 2 terabyte storage capacity of data. Now the vendor says, 2 terabyte, if you want, I can get it, but it's going to take me 6 months to get such a IPC or the HMI which you are asking for. But if you allow me to give you a 1 terabyte one, I can give it to you in say 2 months time. In such a situation, you would take a call whether 2 terabyte is really necessary for you. What can I do? What is a workaround on this? The workaround could be that I do a data transfer from the IPC onto my own central servers so that the data is always there, because data integrity is an important aspect of a user requirement specification, generally a part of automation and control requirement. So the data has to be preserved, but I am not going to generate more than say 1 terabyte of data before I am able to transfer the data onto my server. So I'm okay not to buy a 2 terabyte storage device. I am okay to buy a 1 terabyte storage device and therefore reduce the time required by the manufacturer to give me the equipment. So these are the discussions that you have in such a situation. If you deviate from the signed of URS, you will revise the URS and write a new URS, and you will then place the order for the equipment using your commercial negotiations, or procurement team will do the needful and will place the order. Now, the user requirement specification is important because it was your, don't like to use this word, but I'll still use it, wish list, which you gave to a manufacturer, and he therefore came back with the confirmation that he'll be able to fulfill your wish list. Or a user requirement specification is a specific document which tells what I need in the equipment as a user, and the manufacturer confirms that he's able to fulfill those requirements. Okay. So the URS is a very important document. A well-written URS will give you lesser problems in the later stages of the validation approach. Okay. The second document, most important document, is the design qualification document, including functional specifications. Here I'm combining the two because here the assumption on the start is that we are we are buying the equipment with automation, and therefore functional specification is also an important document here. Now, it is a document which is issued by the manufacturer for review and approval by the manufacturing process team and specifying the design of the equipment proposed by the supplier to meet the user requirement specification. It also includes the functional specification for automation and control system being supplied with the equipment. What does it mean? You have agreed with the vendor your user requirement specification, you place the order on him. Now he has to give you a document called as a design qualification document where he gives you the detail of his how he's going to manufacture the equipment. So this is the user requirement is what you need, design qualification is how that what you need is being met, right? So what would that include generally? It would include a GA drawing. It would include the drawing of the equipment with the dimensions there, saying that this is the dimension of the chamber I'm giving you. This is the dimension of the overall equipment that I'm giving you. This is the way that my piping is going to be there. So a PNID would be there. A three-dimensional drawing would be given, so you know the different elevation in section and how it looks from the three-dimensional perspective, so that you can incorporate into your manufacturing area layout to see that it fits there properly. Details of material of construction used for load contact and non-contact parts along with the specification, finishes, type of welding used, the calculation for pressure vessel design, the system architecture for automation and control, the functional specification, which is nothing but well-written, documented protocol of how the software is exactly going to function. You have a PNID which has got valves, which has got different instruments, which has got different, let's say, start-stop buttons on the HMI. The functional specification actually goes down to specify what happens when you press a button, what happens when you, what are the different screens that you will see. So this is his way of telling you how he is going to build the equipment, the safety features, the utility consumption, how much, what is the size of my steam connection. It's a 1-inch connection, half an inch connection, 2-inch connection. What is the consumption that I'm going to do? Okay, I specified I'm going to give you steam. How much steam will be required to heat up this equipment or to be consumed to reach that 121 degrees centigrade? How much utility is required? Now, you can say, how will he know if he does not know the load? The guys are manufacturing this equipment day in and day out. They will have a fair idea of how much is the maximum consumption of steam which such an equipment can take if it was fully stuffed, and therefore they will give you the maximum utility consumptions which are required, connections which are required. They'll list out all the alarms and interlocks with clear distinction between process critical, equipment critical, and non-critical alarms and interlocks. What does it mean? Interlocks are the functions which are built into the system that will not allow you to do a certain process if because of the interlock. So example, if you had a double door autoclave, unless the door on the back side is closed, the front side door cannot open. The unloading door cannot open unless the loading door is closed. The unloading door cannot open unless the temperature has reached 40 degrees centigrade and the pressure inside the chamber is down to 0 atmosphere or zero point 0.1 atmosphere. So these are interlocks which are built. Alarms are when a condition is abnormal, an abnormal condition is created, and an alarm gets generated. What are the types of alarms? Alarms could be critical and non-critical. Alarms critical are critical to the process or critical for the equipment from a safety perspective and the pressure perspective. Non-critical alarms are alarms which are okay. Maybe one small valve in the line is not responding, but it's still open. It was generally to be kept open. It is open, but it's not giving a signal back or a feedback back, or a particular let's say non-critical alarm could be that one of the lights which is there is not working well. Okay, that's not detrimental to the process, needs to be fixed, but is non-critical to the process to start with. non-critical interlocks can also be there, that certain interlocks are provided which are not life threatening, which are not putting the process under risk or the equipment under a risk. So those are non-critical interlocks. So these are the things that he gives you. Then he gives you the construction feature, the internal finish, external finish, type of welding, as I said, and makes and specification of all bought out components. As I said, that he is not going to manufacture everything in house. He's going to buy stuff. So he's going to buy a PLC, he's going to buy a HMI, he's going to buy an electrical component, he's going to buy an electrical panel, he's going to buy a wire, or a cable, he's going to buy a temperature probe, he's going to buy a pressure transmitter or a pressure gauge and a temperature gauge. Whatever he is buying, these are bought out for him. He will give you the makes and specifications of that. I'm buying a temperature probe from Radix. I'm buying a pressure transmitter from E&H. I'm buying a say a PLC from Siemens. I'm buying a HMI from Simatic, so on and so forth. So he would be required to give in design qualification the makes and the specification of that particular model that he has chosen for meeting your requirement. And these all form a part of design qualification. So once a vendor submits this, and he has to submit it in a reasonable time, the manufacturing team has a responsibility to make sure that it is reviewed. Any discrepancies or any queries which are there are raised immediately and discussed and signed off, because the manufacturer will start building an equipment once the DQ or the design qualification document is signed off. And therefore, it is important to be very, very fast in responding to these DQ submissions made by the vendor. At the same time, generally, this is not that we will wait for all the documents to come in one go. There will be the vendor at the time of order finalization will tell you that I'll first give you the GA drawing along with the PNID. So you approve that. So at least I will start buying my steel. I'll start making the chamber. I will start doing some of these activities in parallel while the rest of the documents are coming into play. So this is a discussion which has to happen at before the equipment is purchased, to make sure what is the schedule in which the vendor is going to give you the complete DQ documentation, and going to make sure that the DQ is completed, right? So that is what is going to happen. Right. Just 1 minute.
Right, good you.
I'll come. I'll just finish this.
I just thought I.
Biocon Academy. Okay, so specifications of all the bought out components have to be specified, and you have to have a schedule in which the DQ gets approved. It has to get approved well in time. Generally, not more than generally an autoclave manufacturer will probably require a minimum of 4 to 5 months to give you an equipment ready for factory acceptance test. I'm talking about a manufacturing facility autoclave of sizes upwards of 1,000 liters or 600 liters. The smaller autoclaves like vertical autoclaves and all are generally readily available with some of the vendors and may be able to give you faster. So in such a situation, their DQs are also generally available, and they should be able to give you as soon as the order is placed. But for a very large equipment where he has to fabricate an equipment, it takes about 4 to 6 months. So in that situation, within 3 to 4 weeks of the order placement, the DQ document has to be completely signed off. If there are deviations, or if there are any certain stuff which are not in agreement, discussions have to happen, they have to be closed. So URS followed by DQ, part of validation approach. Next comes the factory acceptance test, or rather construction. So based on the DQ, the vendor starts constructing the equipment. During the construction phase also, you might have certain tests that you might want to carry. You might go to their factory and make sure that the dimensions are checked, or when he is doing a pressure test, you are present there to do the pressure test, or when he is buying a material, you are there to see the material which he has bought and send it for testing, etc., etc. But those are during the construction phase. But once the DQ is approved and the construction is started, once the construction is completed, the most important part of the qualification process is the factory acceptance test, during which what has happened is that there is a test protocol, which is a written document which is prepared jointly by the manufacturer and the user team. And there are physical and virtual tests which are carried out in the equipment after its construction at the premises of the equipment manufacturer, to demonstrate that the user requirements and the design commitments are fulfilled satisfactorily. Joint tests are carried out by the manufacturing process team and or its representative to check the equipment before it is shipped to the manufacturing location. So factory acceptance test is a very important test which is done. They can be done physically or through virtual means. So during COVID, what had happened was that the pharma industry or the manufacturing industry for pharmaceutical products was running full swing. At that time, people could not travel because of the travel restrictions which were applicable throughout the world. And even within India, for example, in such situations, virtual tests were also conducted by putting camera systems, using virtual reality, AI, and a combination of camera systems to connect online, and the vendor would conduct the test on their own in front of you, and you would be looking at it virtually. Of course, that was true only because of travel restrictions. But today, in most of the cases, you physically go to the site and conduct it. But everybody cannot travel. For example, I just returned from a trip to Europe where I had gone for a factory acceptance test of a particular equipment, and there were only three of us who could physically be present at the vendor's site. But there was a team which was sitting in India and was sitting in another location in the world where the manufacturing location is, in the Middle East. And the people from there got connected virtually onto the time that we were doing the test on the machine along with the vendor to witness the test. So this is a test which is carried out so they can see what is happening virtually. We were doing it physically there along with the vendor, and there was an interaction. Today, because of the means of communication, it is possible. There was a time when these means were not available, so virtual tests were physically impossible. And you had to be physically be present there, or you had to rely sometimes on the manufacturer to perform the test and send you the relevant documentation, which is also an acceptable stance. You cannot always go for a factory acceptance test. Sometimes it is difficult for you to physically be present. Let's say there are five equipments which have come up for a factory acceptance test simultaneously. The team which is handling the installation of a new facility could be limited to say five people, six people. In that situation, not everybody can be traveling. In such a situation, you are allowed by the regulatory also that the factory acceptance test be conducted by the manufacturer, and they share the results. And once they share the results, you review those results and say, yes, it is good to go. Okay. Also, please remember that the manufacturer does not want to dispatch an equipment without a proper testing. Otherwise, he will have to spend his resources to get it rectified at your factory. So, factory acceptance test is going to be done, generally done physically with a combination of virtual test sometimes. Not mandatory that virtual tests have to be always be present, but physical tests are there. For example, softwares can be tested through a bench test virtually. You don't have to be physically be present. You can test the whole software virtually sitting in your premises and the vendor sitting in his premises. So various permutation combinations are possible, but a factory acceptance test is an important aspect of qualifying an equipment because it tells the manufacturer that he has fulfilled the user requirement and the design commitments, tells the user that whatever he or she had envisaged as a user is being met and is in alignment with the design qualification which they had signed. Any small defect, sometimes the finish may not be right, sometimes a particular gasket may not look right, or sometimes you may see a certain location of a certain valve is he has put it there because for him it was easy to stuff it in, but then when a maintenance guy looks at it, he says, how the hell am I going to maintain this? How can I open this valve easily? And he therefore comes and says, no, this accessibility is not okay, I need a little more access to be created around these files. So these are not small things, these are very important aspects, but get rectified at the factory level, because at your side to do these changes is sometimes impossible. And therefore, it is better to do a proper, thorough factory acceptance test. Only after the factory acceptance test is successful do you give a dispatch clearance. So the manufacturer then dispatches the equipment to the manufacturing location. A lot of times what happens is when you go for a factory acceptance test, you create what is called as a observation list, or what is technically, or in the language that all of us use in the industry, is called as a punch list. A punch list is provided to the vendor saying that these are the items which are not fulfilled, may not, you need to correct certain things, like as I said, finishes. These are generally not these are not very critical part of it. If it was a critical failure, then you would not even accept the factory acceptance test and may have to go again for a factory acceptance test. But these are observations which are made, which the vendor can do it, and he fulfills the punch list, provides you evidence, and then you say, okay, you have met all the observations which were made, are satisfactory, and now you can dispatch the equipment. So factory acceptance test therefore becomes a very important stage of the entire validation of an equipment, because with that you are 100% sure that the equipment that you are getting is made as per your URS and as per the design commitments made by the vendor. Now going to installation qualification, now the equipment has reached your site, right? Now it has reached the manufacturing site. You need to have a process which is documented, of course, to make sure that the equipment is installed, meeting all the specifications of the facility and the user requirement which were there. So user requirement DQ. So it's always that you do not discard a previous document before, because you are doing the next step. It is always a reference from where you qualify the next step. So you had the URS, the DQ, and the FAT, or factory acceptance test, which is called as FAT in short form. This is the documents which you will use during IQ to make sure, yes, have I installed it correctly? Has it been placed properly inside the facility? Have I connected the utilities correctly? Have I done the electrical connections right? Because please remember, when the manufacturer dispatches the equipment, he's going to dismantle the equipment so that it can be transported easily and it will arrive at your site. Once it arrives at your site, he's going to reassemble the equipment. In such a situation, you need to make sure that the components are rightly installed, they are correctly installed in the right place. It is not a complete dismantling, it's a part dismantling, but whatever part has been dismantled has to be installed properly. So you're doing that check. Then the supporting programs needed for ongoing operations, like standard operating procedures, maintenance programs, are in place. So during IQ, you have to make sure these are in place. And the IQ generally includes the following checks: the mechanical equipment checks, whether it is installed correctly, the floor is level, that there is no slopeness, one side of the equipment is not lifted up because of the floor being uneven or whatever it is. It can happen, right? If the floor is uneven, you are supposed to keep an autoclave in a 0-0 position, because that is how his drains inside the chamber are connected. Now you start to place it where the backside is tilted upwards. You're never going to have a drainage happen in such an equipment. Even at the drainage of the slope that we are verifying here is something like 1 in 100. Okay, so even that kind of a difference can sometimes lead to drains not being proper. So very important that the mechanical equipment checks are done. Site infrastructure interface checks, whether I've connected the utilities correctly, the power correctly. Component verification, where all the components which were supposed to form a part during factory acceptance test, you check all the components, valves, pipes, everything. Now they were dismantled, they were reassembled. As everything come back, is it in the right place, right position? Is the tag correctly put that this is the temperature probe number 1? It is supposed to be here as per PNID. It is there. 2 is here. 3 is here. It's not. It got interchanged for whatever reason. Documentation verification, whatever documents was supposed to be handed over by the manufacturer, material test certificates, weld certificates, PNIDs, as-built PNIDs, as-built GA drawing, as-built drawings, whatever be your documentation. Remember, in the URS you had a document list which was the responsibility of the vendor to give it to you. You will make sure that you will verify some of this during factory acceptance test, but the whole bunch will come to you at the time of IQ that you received all the documents, because this is the equipment document which you will file it in your quality assurance for the auditors to be able to check over a period of time. For you to be able to run the equipment itself, you need these documents. And apart from this, the auditor who's going to come and audit your facility is also going to ask you for these documents. URS is going to ask you, DQ is going to ask you, IQ is going to ask you. Installation qualification is called as IQ. So there are protocols written around it. Installation qualification is done. Operation and maintenance manual should be available. Piping and PNID installation verification is done. Whether the piping is installed right, whether the slope is correct, whether the PNID components are correct, whether temperature sensors, valves, everything is properly in place. And instrumentation calibration checks are done. You've received the instruments. Is the calibration valid? Because remember, I told you that autoclave will take 6 months to build at times. Now, the vendor might have purchased the temperature probe when he started the manufacturing. He might have received the probe at that time and it was calibrated at that time. The calibration has an expiry date. Generally, it is about an year. Sometimes the manufacturer of a temperature probe might have the temperature probe lying at his workshop for 3 months before he sold it to the equipment manufacturer, which means that there was only 3 months of calibration left when the equipment came to you. Now you do not want to run an equipment for 3 months and then do the calibration. So you might want to do the calibration of all instruments when it arrives at your site, and it can be done at your site a lot of times. Sometimes instruments have to be sent out for calibration to a third party laboratory. In such situation, you will send them out. This is all done during installation qualification. Before you start the next step, which is operational qualification, your installation has to be 100% pakka. Your instrumentation has to be calibrated. Without calibration, you cannot go to operational qualification. So IQ becomes an important part. Now, operational qualification. Now you install the equipment. You specified the equipment. The vendor designed it as per that. You did a factory acceptance test. You installed it at your site. Now you have to operate the equipment. So you have to do what is called as operational qualification. You will run operational qualification tests into it. You will run power loss recovery. Remember, I spoke about power loss. Power failure happens. What happens? Can you recover the cycle, or can you not recover the cycle? Because these are not factors in hand of a equipment manufacturer. These are your site infrastructure related situations which you need to simulate and test. So it's not that you will have a power loss, you will wait till a power loss happens. You will simulate a power loss. How do you simulate a power loss? Go to the panel and switch off the power coming to the autoclave, and then switch it on after 5 minutes and see what happens. Power loss recovery test. automation and control functionality, whether everything on the software is running as it was demonstrated to you during factory acceptance test. The source code is reviewed during this time. Sometimes the source code can be reviewed earlier, but generally you want to see whether you will check whether the software version number is correct, whether it is integrated properly. If you are taking the data from the software onto your own servers on the company server, then you have to make that connectivity and make sure that that path of transfer of data from the equipment to your server is correctly functioning. So that may require a source code review. So automation control functionality is done. You do a leak test, you do a pressure roll test, you do a vacuum hole test, you do an air removal test, you do a filter sterilization test, you do a air removal, steam penetration test, empty chamber test, temperature mapping. You place temperature probes throughout the chamber to determine which is the cold spot or the temperature probe based on which you want to start your dwell time. Okay, so these are the tests that you will do during operational qualification. Your cycle validation with the load will happen during OQ phase. Okay, you part of it will happen during OQ phase. The half cycle time will happen during OQ phase. The full one will happen during PQ phase. So these are empty tests generally where you are making sure that operationally the equipment is running fine. There are no problems when you run the automation, when you run the leak test, when you run the pressure roll test. Some of these tests you may have done during factory acceptance test, but you will repeat it during OQ. Not all tests have to be repeated. For example, dimensional check, right? The dimension of a chamber is not going to change after you have checked it at the FAT. The vendor is not going to add extra piece of chamber or cut a chamber after you have determined it, right? You may not need to do, let's say, certain checks on terms of components also at times, or a vacuum pump, whether the vacuum okay model number is correct, check during IQ. I don't have to switch it on and run it again during OQ. I may have to run it from a vacuum test of the chamber, but I don't have to run the vacuum pump on a blind, meaning on a shut off condition to see whether it is running fine or not. So today there is a big push towards making sure that you are able to cut down your overall time to start manufacturing, and therefore you can leverage some of the tests which you have done during factory acceptance test during your site test, which is IQ OQ. You can leverage them, saying I will not repeat the test because these are factors which are not going to change when the equipment gets dispatched from a factory and reaches my site. Dimension was one of the things, for example, which I told you. Dimension of the equipment is not going to change. Why should I verify it again when it comes to my factory? It's a waste of time. So I will leverage that. I may have checked a lot of documentation already while I was doing my factory acceptance. I don't need to recheck those documentation because they are already checked and already available. So I don't need to waste time checking it. Therefore, I can cut down the time required for qualification at the site. But this is a factor which has to be considered very carefully. Okay, so when you are at the DQ stage and after you've approved the DQ, you have to write the factory acceptance test protocol. You have to agree with the vendor that what are you going to do during factory acceptance test, what all is he going to demonstrate to you, how much time are you going to spend in FAT, because you may be spending just 2 days at the factory for factory acceptance test, or you could be spending 5 days for a factory acceptance test. During those 5 days, what every day, what is the test that you are going to run? What are the tests you are going to run? What is the acceptance criteria for you? I think in quality systems, you have come across the concept of acceptance criteria. So those acceptance criteria get defined in these test protocols. You did at that time itself, you determine what will you do during IQ and OQ. So FAT, IQ, OQ, you kind of outlay what will happen when, and then write the protocols accordingly and make sure that wherever you want to leverage and are allowed to leverage and can leverage, you will leverage it. But wherever you are absolutely required to test so that you are satisfied at your site, you will make sure that it is included in the relevant protocols. So the protocol sign off is a mandatory requirement before you start any of these. So before you start a FAT, DQ has to be signed. Before you sign off a DQ, URS has to be signed. Before you start an IQ, your FAT report has to be closed, meaning your test is completed and you have accepted the FAT has to be signed. The IQ protocol has to be pre-approved, meaning what are you going to do during IQ has to be pre-approved. The protocol or the procedure has to be pre-approved. Then you execute it, you generate the execution report saying I have executed the IQ, it is running fine, and therefore I'm certifying that this test is satisfactory. That's called as a report. And you cannot sign a OQ. Pre-approval can be done, but you cannot initiate the OQ till the IQ is signed off. Matlab, report is closed. And after the OQ is done, you will do the OQ closure saying that, okay, OQ is fine, and now I can go ahead with the thing. Based on the IQ and OQ, your training will happen to the people so that they get trained on the equipment, they get the all the SOPs get finalized. So I wrote about standard operating procedures here. These standard operating procedures drafts may be available during IQ. They get finalized by the time OQ gets happened, and this is the time when it is ready for cycle development. Now OQ sometimes accepts cycle development as a part of it, or sometimes it is done later on as a part of PQ. As I said, half time cycle can be run during OQ itself, but just to get a feel of what your load, how your loads are performing. Okay. Sometimes people also put the responsibility of the cycle development onto the vendor and say that I will give you the loads, these are my loads, and you will have to develop the cycle and give it to me. And they will develop the cycle for you. You will validate the cycle in the performance qualification. The last phase of the equipment is, of course, cycle development and performance qualification. This is a phase of qualification in which sterilization cycles are developed. So, as I said, cycle development could be done by the vendor or is done by you in-house, depending on the experience and the confidence that you have. And the cycle developments have to be done first. Once the cycles are developed, then you have to validate the cycle. So you will run these cycles repeatedly till such time that you will get a 3 consecutive successful sterilization cycles for a given load and given set of conditions for that load. And that is what will say that you have qualified the equipment from a performance perspective. Okay. Decision on lot configuration, I spoke about it a little bit in the earlier session. You have a fixed load, fixed position, meaning your quantity is fixed. What is going to go into that load is fixed, and the position is also fixed. The second type of load is variable, fixed load and variable positions. The most likely situation in the industry is the second one, that your load quantity is fixed, but when the operator is loading it, he might make a few, he might be ending up making a few changes, and these are not necessarily always errors. Sometimes it is also on time of loading. The when he is placing something, there is a slight placement which has been done in a different way. Instead of placing it horizontally, the load was placed vertically, and this can happen because at the end of the day, please remember that the operator is a human being, and when they are loading it, it is not always the same way of loading. I may load it in a different way as compared to somebody else. Meaning, I know where the load is put, but I might place it slightly in a slanted way, or I might put it in a horizontal instead of vertical. The position remains the same, but there will be a slight variation in the position itself. Or I might put it on the top instead of bottom, or whatever reason, because and that day when I was loading it, I saw that there was probably some space occupancy. I did not coil the hose properly, so maybe it occupied a little extra space, and therefore I had to place another component elsewhere. The quantity remained the same, so the fixed load quantity is the same, but the position slightly varied. No issues, very likely situation, but the same cycle should work. Variable loads, variable position, this is generally the most differential part of it, where you have variable loads, where the load pattern changes, the quantity changes, position also changes. This becomes difficult because then you will go to an overkill approach here and do it. But during cycle development, you would have taken these three types of loads: fixed load, fixed position, fixed load, variable position, variable load, variable position, and determined your cycle. So determining based on the batch that you are running, you can decide which of these cycles is applicable to you for the autoclave and go ahead and run that cycle. And for a cycle development to be considered successful, one must achieve 3 consecutive cycles for each type of load and lot configuration, resulting in no growth and hence demonstrating stability assurance. So very, very important aspect that without this, you can't consider this. With this, I come to the end of the cycle validation approach. Open for questions and answers now, and thank you for your attention, but open to questions. So students, please ask questions where you have.
Sir, I have one doubt.
Yes.
Sir, what is commissioning and decommissioning?
Okay. Commissioning is a part of the phase which is combined generally with OQ. Commissioning is what is when you have placed the equipment at your site, at the manufacturing site. It is run to demonstrate that it is working fine in the conditions of your site. So commissioning is generally a word which is no longer used for process equipment inside the core process area. You would use IQ, OQ, and site acceptance test, which is a part of IQ and OQ, as the equivalent of commissioning. But commissioning is still a terminology you will see being used for plant utility equipment. A boiler gets fired and you are able to generate the quantity of steam and the pressure of steam in the boiler inside your plant utility. That's commissioning of the boiler. Here, in the context of the autoclave or in context of the process equipment, once you have completed IQ and OQ, it is generally equivalent to having commissioned the equipment itself. Commissioned is nothing but having tested at your site. Clear?
Yes, sir.
Any other questions?
Okay, if nobody has any questions, means I will stop here. Thank you, sir. Thank you for your time, and we'll meet on next week on Monday for your quiz.
Yeah, 16th is the next session, right?
Yes, sir.
For me, 16th is the next session. 16th April, 1 second, please. Yeah, 16th and 17th, we are going to have 2 classes, so we will meet at that time. Thank you very much. The question and answer for the quiz will be mailed later today.
Thank you, sir.
Right.
Thank you.
Thank you so much.
Thank you,
Thank
sir.
you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank
Thank you, sir.
Bye.
Thank you.